Hi there, my name is Alan.
My name is Donald.
And I'm Tynan.
This is our 154 and 106 joint project.
We're going to be talking about the purpose, the motivation, how our linkage system on top works, and our results from our stress analysis.
Our project is a non-traditional H-type vertical axis wind turbine, which changes its pitch angle depending on the direction of the wind. It does that with the help of the 4-bar linkage up top.
The motivation of this project is due to the growing problems in global warming. The renewable energy is the way to slow the effect down, and because we're doing a mechanical design project, we pick a wind turbine. We noticed that there is a limitation in efficiency, so we would like to come out with a solution to increase the efficiency.
So I'm going to be talking about the components that make up our wind turbine. It's made mostly out of aluminum with some steel components. Our airfoils are made out of PLA, they're 3D printed. If you look at our offset link up here, it's holding 3 thrust bearings, which allow these 3 aluminum links to rotate independently. The purpose of our mechanism is if there's a wind vane on top, and what happens is the wind flows and pushes the wind vane back, and it forces the offset link into the correct position, which then moves the links and changes the pitch angles of our airfoils.
So the main purpose of the wind vane is to create a moment on the bolt over here which connects all the other links, so that the ground link right here would stay stationary parallel to the airflow. So if you see here, the main purpose of this location is so that the wind could hit this foil with the maximum amount of drag force on the most amount of area, while the other two, while this one is hitting it head on, and due to the streamlined body, it doesn't get much force on it. And if you look over here, you can see how the mechanism works.
For the mechatronic part of this project, we used an H-bridge to control the generator. The generator requires a 2-quadrant operation, therefore we only send signal to in1 and in4 pin. When it is charging, both in1 and in4 is high, so the motor won't see any voltage difference, hence we won't spin. When we want to break it, we set in1 high and in4 low to create opposite torque to the motion. We also limit the voltage output into the motor from preventing full 12 volt opposing torque that may eventually break the mechanism. In terms of decision making, we connect NA and NB in 1 and in 4 into Arduino board. By setting the NA and NB, we control the percent duty cycle of voltage going into the motor. By setting up the in 1 and in 4, we control the direction of the operation. We also use the Hall effect sensor to detect the speed of the shaft. We use if loop for the Arduino to decide which operation does the turbine needs. We use the code to calculate the RPM, and if the RPM is faster than the design RPM, the brake turns on.